In our previous session, we discussed capital productivity. Today, we are going to explore a new topic, labor productivity. Have you ever wondered what drives the efficiency of an organization and how businesses achieve more with the same resources? In this session, we will explore the concept of labor productivity, a key measure of organizational performance. Together, we will define what labor productivity truly means and, of course, breaking down the essential steps organizations take to enhance it, paving the way for sustained growth and success. At the end of this topic, you will be able to define labor productivity. And of course, you'll also be able to list down the steps of labor productivity in organizations. To begin with, labor is a key component of production and manufacturing, as it plays a critical role in transforming raw materials into finished goods. Skilled and unskilled workers contribute at various stages, from operating machinery to assembling products. Labor ensures that production processes run smoothly and efficiently, turning materials into market-ready products through both physical effort and decision making. Without labor, raw materials would remain unprocessed and production would come to a standstill. Furthermore, labor refers to the physical, mental, and social effort used to produce goods and services in an economy. It supplies the necessary expertise, manpower, and services to transform raw materials into finished goods and services, playing a crucial role in driving economic production and meeting market demands. In addition, labor is essential in the manufacturing process and plays a key role in converting raw materials into finished goods. It can be broadly classified into three types. Number one, skilled labor. Number two, semi-skilled labor. Number three, unskilled labor. Skilled labor. This category includes workers who possess specialized knowledge or training in a specific field. Skilled laborers such as engineers, mechanists, or technicians are responsible for operating complex machinery, troubleshooting technical issues, and ensuring that production meets high quality standards. Their expertise enhances efficiency and productivity in the manufacturing process. Semi-skilled labor. Semi-skilled labor requires some training or practical experience, but does not demand extensive expertise. These workers often perform routine tasks or operate machinery that require less technical skill. For example, assembly line workers or machine operators contribute significantly to the production process by following instructions and maintaining workflow consistency. Unskilled labor. This type of labor involves workers who perform tasks that do not require specific skills or training. Unskilled laborers are typically involved in manual tasks such as material handling, packaging, or cleaning, which are essential to keeping the production process running smoothly. While their roles are less specialized, they provide the necessary support to complete the manufacturing cycle efficiently. Together, these types of labor ensure that the manufacturing process operates effectively, contributing to the conversion of raw materials into valuable products. Labor productivity is an important metric used to assess the efficiency of the workers in a production process. It is calculated by determining the number of products produced per hour for an individual. This measure provides insight into how effectively labor is contributing to the manufacturing process and helps identify areas for improvement. The formula for calculating labor productivity is equals to number of products produced divided by hours worked. This means that for any given period, labor productivity can be assessed by dividing the total number of goods produced by the total hours worked by an individual or team. For example, if a worker produces 50 units in 10 hours, their labor productivity would be 5 units per hour. Measuring labor productivity helps business optimize their operations set performance benchmarks, and improve efficiency. It allows managers to monitor workforce performance, allocate resources more effectively, and make informed decisions about hiring, training, or investing in new technologies that could increase production capacities. Continuing with this theme, measuring the time required for a task is critical in optimizing productivity and ensuring efficiency in production process. Two primary tools used for this purpose are motion study and work measurement. Each of these techniques plays a significant role in understanding and improving how labor is used in completing tasks. Motion study. Motion study is a tool used to analyze the physical movements required to perform a task with the aim of eliminating unnecessary motions and streamlining the process. The objective is to identify the most efficient method for carrying out a task by studying the worker's physical movements, tools, and sequence of actions. By eliminating wasteful or repetitive motions, motion study helps improve efficiency, reduce worker fatigue, and accelerate task completion. Work measurement. Work measurement is a technique used to determine the standard time it takes to complete a task. It establishes a time baseline by analyzing how long it should take an average worker using the most efficient method to perform a task under normal working conditions. Techniques used in work measurement include time study, whether the time taken to complete tasks is recorded and analyzed to set time standards. Predetermined motion time systems, that is PMTS, which use established data for common motions like reaching or grasping to calculate total task time. Work sampling, which involves periodic observations of workers to estimate the proportion of time spent on different activities. And standard data, which uses pre recorded time values from similar tasks to estimate the required time for current tasks. Furthermore, continuing with the measuring labor productivity, standards in work measurement are set with consideration for differences in worker performance and allowances for relaxation needs, recognizing that human beings require rest and recovery to maintain efficiency. Factors such as job transitions, trials, tools inspections, and adjustments must be accounted for when establishing these standards. Additionally, monotony, challenging working conditions, and task complexity can reduce productivity. Therefore, addressing these issues by reducing stress and fatigue is essential. Superior job design should incorporate elements that mitigate these stresses, enhance working conditions, and create a balanced workflow to optimize productivity and worker well being. Now, let's transition to the steps involved in enhancing labor productivity, which are crucial for optimizing efficiency and output in production operations. Here are the key steps. Number one, balancing operations in assembly line. This involves distributing tasks evenly among workers to prevent bottlenecks and ensure a smooth flow of production. Reallocation of workers. This step focuses on strategically assigning workers to roles that best match their skills and capabilities, enhancing overall efficiency. Number three, setting up productivity norms and evaluation of production operations. Establishing clear performance standards and continuously assessing production processes to identify inefficiencies and improve output. Let's delve deeper into each step. Step 1, balancing operations in assembly line. Balancing operations in an assembly line is crucial for enhancing productivity as it ensures that the product moves seamlessly through various stages of production towards completion without unnecessary delays. For example, in a car manufacturing assembly line, if the painting station is slower than the assembly of the parts, it can create a backlog that slows down the entire process. By identifying this bottleneck, managers can redistribute tasks or adjust the workflow to maintain a smooth progression of work. Addressing the variability in the speed and efficiency of the different tasks is a major concern in this balancing act. To keep the overall workflow steady, additionally, workers may need to be assigned to specific tasks that require more time due to their complexity. For instance, if a bottleneck is anticipated during peak production periods, managers might hire temporary workers or adjust schedules to ensure that every stage of the assembly line operates efficiently. Moreover, personal needs of the workers, such as breaks or unforeseen absences, can disrupt the flow of operations in such cases. Having additional personnel on hand can help mitigate these interruptions. For example, if one worker on the assembly line needs to take a break, an extra worker can step in to ensure that the workflow remains uninterrupted, allowing production to continue smoothly without any delay. By effectively balancing operations and ensuring adequate staffing, companies can optimize their assembly line efficiency and improve overall productivity. In continuation to step 1, balancing operations in the assembly line involves improving jigs and fixtures, adopting new methods, and relocating jobs to align with the mapped competencies of workers. It is essential to identify bottlenecks in the production process and develop strategies to alleviate them. Additionally, balancing the time taken at all stages of assembly ensures that work continues with minimal delays, which helps in minimizing inventory levels. By implementing these practices, organizations can enhance overall efficiency and streamline their operations. Next, we move on to step 2, reallocation of workers. Reallocation of workers is a crucial step that occurs at the start of operations to ensure optimal productivity. This process is based on a careful assessment of job descriptions, the specific requirements of machining centers, and the skills of the workers. For example, in a manufacturing facility that produces electronic components, workers skilled in soldering is assigned to a station that primarily requires assembly. Their skills may not be fully utilized. By reallocating this worker to the soldering station where their expertise is needed, productivity can be significantly enhanced. Furthermore, bottlenecks in the production process can only be cleared when the rates of the production at different workstations are equalized. This can be achieved by increasing capacities at intermediate positions, which may involve adding another machine or allocating an additional worker. For instance, if the assembly line for a product is experiencing delays because the packaging station is slower than the assembly station, adding an extra worker or machine at the packaging station can help balance the workload and eliminate the backlog. This reallocation leads to better utilization of equipment and results in smoother throughout, ensuring that the entire production process runs efficiently without interruptions. By effectively reallocating workers, organizations can optimize their operations and improve overall productivity. Now, let's discuss step 3, setting up productivity norms and evaluation of production operations. Setting up productivity norms is essential for optimizing production operations, and this process often utilizes various methods, including time and motion studies, as well as the predetermined motion time systems (PMTS). Time and motion studies involve analyzing complex tasks by breaking them down into smaller, manageable steps and measuring the time required for each step. For instance, in a food processing plant, the process of packaging products can be dissected into stages like filling, sealing, and labeling. By timing each step, managers can identify the most efficient methods and set performance standards. Once these productivity norms are established, they serve multiple purposes in the planning and control of production. For example, with standardized time measurements in place, managers can more accurately estimate pricing for products and determine delivery times based on expected production rates. Additionally, these standards can help in devising incentive schemes for workers. For instance, employees may receive bonuses for exceeding the set productivity norms, encouraging them to work more efficiently. By continuously evaluating production operations against these established norms, organizations can identify areas for improvement, ensure optimal workflow, and enhance overall productivity. Continuing with the step 3, when setting up productivity norms, it is crucial to establish specific standards for different jobs based on the basic motions involved and the time required to complete them. For example, in a textile manufacturing facility, norms might be set for various tasks such as cutting fabric, sewing, and quality inspection, with each task analyzed for its fundamental motions and the average time needed to complete them. This approach helps in ensuring that the expectations are realistic and achievable. Additionally, system efficiency plays a significant role in fixing productivity norms. For instance, if a particular production line operates at 80% efficiency, this factor must be incorporated into the productivity standards to provide a more accurate reflection of actual performance. Production operations are then conducted and measured in terms of quantities produced and the time required for completion, allowing for a comprehensive understanding of the workflow. These operations are based on sequencing tasks, managing the loading of materials, and coordinating dispatching to ensure timely delivery. For example, in an automotive assembly plant, the sequence of the operations is critical. If the assembly of the parts is delayed, it can have a ripple effect on the entire production line. To address any shortfalls in productivity, companies may resort to overtime work or subcontracting specific tasks to external vendors. For instance, if a deadline is approaching and the in house workforce is unable to meet production targets, subcontracting some assembly work can help ensure that orders are fulfilled on time. By continuously evaluating and adjusting productivity norms, organizations can enhance their operational efficiency and respond effectively to production demands.
So, at the end of this topic, we can learn that productivity increases when the product moves through the various operations towards completion without any holdover. So, the main focus will be balancing the time taken at all the stages of assembly or the manufacturing processes so that the product our workflow with the minimum delay. This happens by either improving the tooling or adding another machine or by allocating an additional welcome. Hence, this unit will have elevated that the labor productivity and how labor is important for the production, how the labor is required at a particular machine and time, and how the level will be segregated on the basis of the earth nature, on the basis of the product nature, and on the basis of tiny requirements for the explanation of that particular content. And this process of relocation should result in better utilization of equipment and smoother through output. So next unit we will focus on personnel productivity, which will give you that how a personnel is required for production, what is the use of personnel, and how we cope up with the personnel in production and operations management. That's all for today. Thank you. Happy learning.